is Pre-Calc 11, Chapter 6.4. This time we're going to be looking at the sine law, and we're also going to be looking at the derivation. So the sine law is useful for all triangles, because not all triangles contain right angles. So let's look at this triangle. If we draw the height here, and it's a right angle, we can see that h equals b sine c. H also equals c sine b. Since these are both h's, we can make b sine c equal to c sine b. And with a small rearranging, we get b over sine b equals c over sine c. Or we can use sine b over b and sine c over c. And note, we use capitals for the angles and we use lowercase for the side lengths. Now, taking the same triangle and rotating it so that side C is on the bottom, let's draw the height of the triangle again. Now we just go through the same procedure. H equals A sine B. H also equals B sine A. So A sine B equals B sine A. And A over sine A equals B over sine B. And we also have the option of doing sine A over A equals sine B over B. And we can use a math concept called transitivity, because we have sine B, because we have B over sine B and B over sine B, we can make A over sine A equal B over sine B equals C over sine C. So we get the same thing. A over sine A equals C over sine C. And of course, we can flip them all over. Now, why would we need both? Well, it saves you a little bit of algebra. So if you're looking for the angle, then you would use this formula. If you are looking for a side, you would use this formula. But we'll see this in an example. And I've already said it, but just it's important to note that not all triangles have right angles. And the reason why we have two formulas is we want to put the unknown in the numerator. It just makes it easier to solve. Okay, let's look at the first case. We have angle, side, angle. And we're asked to determine all sides and all angles. And we can't use the sine law yet because we don't have an angle and a side. However, we do know that the triangle has 180 degrees. So we just subtract off the known angles, 62 and 56, and we get 62 degrees. Now we can go ahead and calculate A and B. B over sine B is 62 degrees equals, we know side C, so that's 13 centimeters over sine 62 degrees. And we get B equals 13 centimeters, and we have sine 62 over sine 62. So B is simply 13 centimeters. Now we have A over sine 56 equals 13 centimeters over sine 62. This could be B or C. It doesn't matter because they're both equal. So we have A equals 13 centimeters times sine 56 over sine 62. And this time we'll have to use a calculator because the numbers are different. Always check your mode. It's in radians, so I need to switch to degrees. And we do 13 times sine 56 divided by sine 62. And this is approximately 12.2 centimeters. Okay, so this is angle, side, angle. If we have angle, angle, side, we can go ahead and use the sine law without doing this calculation. But if you need all sides, you should do this calculation anyways. And let's look at the case of angle, side, side. And we're asked to determine all angles and sides again. So we have A, angle A, and side A. We have side C, but we don't have angle C. So this is the first angle that we should solve for. And again, we don't know what the angle is, so we should have the angle on the top. Sine C over 4 equals sine of A, 63, over 5. So this is A. Sine C equals 4 over 5 sine 63 degrees. C equals inverse sine 4 over 5 sine 63 degrees. And it's best to do this all in one go rather than figuring out this value and then doing the inverse sine. This will give you the most accurate calculation because we haven't rounded anything off. Now, we'll go to the calculator, inverse sine, 4 sine 63 divided by 5. And be careful where you put your brackets. We have a right bracket divided by 5. Do not put the 63 divided by 5 and then 2 right brackets. Enter. So we have 45 degrees. And let's label this 45 degrees. Best to circle our answers. Now we determine B, and that's 180 minus 63 minus 45, and we get 72 degrees. Let's put this in here, and we'll circle that. And finally, we need to calculate side B, so let's put B on the top. B over sine 72 equals, you can choose any one you want. I'll choose A. And again, it's better to choose A because these are given values, whereas angle C is an approximation. Because C is an approximation. Okay, so B equals 5 sine 72 over sine 63. And we can enter this directly on the calculator without any rounding errors. 5 sine 72 divided by sine 63. And we get 5.3. That's probably enough decimal places. 5.3 centimeters. And we have 5.3 centimeters. And that's triangles complete. Okay, now it's very possible that ASS is not a triangle. And there's a reason why we say ASS versus SSA. It's to remind you to be careful because you do not want to assume anything. So let's draw out this triangle. So this is 30 degrees. That's A. And this is 2 meters. And B is 10 meters. So we don't know where B is exactly at this point, but let's call that one C. If we try to use the sine law, sine B, so we're trying to find angle B, and we have 10. And for A, we know we have sine 30 over 2. So sine B equals 10 over 2 sine 30. So B equals inverse sine 5 sine 30. Okay, 10 divided by 2 is 5. And now we try to do this on the calculator. Inverse sine 5 sine 30. And we get an error, domain. What does this mean? Well, if we look at it closer, inverse sine, and we do this calculation, 5 sine 30, we get 2.5. However, the range of sine theta goes from -1 to 1. That means the domain of inverse sine is -1 to 1. So there's no solution. And visually, if we look at this 2 meters just can't reach this line. It's just not long enough. So that's another way to explain the error. So you can look at the domain of inverse sine, and you can look at the triangle itself. So what else can happen with the ASS triangle? We can get two solutions. So let's draw a triangle again. And I'm just going to draw that out like that. So we have 30 degrees, that's A. We have B is 10 meters. We have C, and we have A. So A equals 6 meters. And what's happening here is 6 meters is long enough to touch this part of the side and this part of the side. So in fact, we have B1 and B2. So sine B1 over B equals sine 30 over 6. So B1 equals 10 over 6 sine 30. And I should put the degrees there. So B1 equals, oops, this is sine, and then B1 equals inverse sine. This reduces to 5 over 3 sine 30. And this is approximately inverse sine 5 sine 30 divided by 3. And that's 56 degrees. So we can calculate C now, and we'll call this C1 equals 180 minus 56 minus 30, and that's 94 degrees. And we go ahead and use the sine law. Little c1 equals, and we'll use our 6 meters again. And this is sine 94 over sine 30. And we have approximately 12.0 meters. Okay, let's look at B2. We know that sine is positive in the second quadrant. So we use our second quadrant formula, 180 minus 56 degrees. That's 124 degrees. So C2 equals 180 degrees minus 124 degrees minus 30 degrees. And that gives us 26 degrees. So we have another number. So little c over sine 26 equals 6 meters over sine 30 degrees. So little c equals 6 sine 26 over sine 30 is approximately 6 sine 26 divided by sine 30, 5.3 meters. And that completes that triangle. So let's go over the rules for ASS. There's actually rules to determine whether you have no triangle or a triangle with two solutions or whether it's a single solution. Okay, so let's draw the triangle to make it clear. So we have A, B, C1 and C2. We have side C, we have side A, and this is side B. So B could be here or all the way over to here. So if A is less than C sine A, and again, you have to be comfortable using different letters for different triangles. Just work with what you've got and figure out how these relate. So if we have this case, then we have no solution. So the rule for two triangles, if any of these rules fail, then you have one triangle. So if A is less than 90, then we might have it, but it has to have all these conditions. If A is less than C, so A is smaller than C. If we have C smaller than A, then it has to go that way. It can't come back this way and still be a triangle. If A is greater than C sine A, okay, so A must be longer than the right triangle length. So if it's longer than the right triangle length, it could form two different triangles. And again, if it fails on any of these conditions, it's a single triangle. So let's test our knowledge and see if the following are ambiguous or not. Okay, this is less than 90. We're using this as our main one. So it has to be B is less than A, and that's true. We need to compare 5 to 20 sine 60. And 5 is actually smaller than this, so it's not a triangle. Okay, so we can test this on the calculator. 20 sine 60. That's 17 meters. So what we have is this case, 17 meters, 60 degrees, 5 meters. It just won't reach the other edge. Okay, we got big B. So B is what we're working with on this side. So 9, and this is less than 90, and this is smaller than that. So now we're testing 10 sine 60. Okay, 10 sine 60. And we get 8.6. So this is greater than, so we have two triangles. Okay, again, this is less than 90. This is bigger than 9, so C is greater than A, so not ambiguous. And if you wanted to say this is ambiguous. Okay, and one more. So we have C. So we're putting C in here, and we're going to put A in here for the C. So first of all, is C less than A? Yes, it is. So we go through the final step. We check 11 versus 13 sine 40. 13 sine 40. 11 is greater than 8. So again, we have two triangles and it's ambiguous. And that completes this lesson.